Today I am going to discuss DL configuration. Now this DL configuration is very important in biomolecules. DL configuration is relative configuration, means here we have to take a standard measure as standard molecule. We are going to use this molecule. It is called glyceraldehyde. Now you can see here in glyceraldehyde, this one is aldehyde group, alcohol group, then CH2OH group and hydrogen group is there. Hydrogen is there. Now in this molecule you can see CHO, that is major group, strongest group. So it is on upper side. Then comes CH2OH, it is on downside. Then OH, that is on right hand side, and lastly hydrogen, it is on left hand side. Now this is the standard configuration and it is called D configuration. Here you can see D configuration. Now you can see this structure in glucose, CHO, that is on upper side as such, you can see. Now CH2OH, that is on downside. You can see this carbon, I am taking this carbon as middle one. OH, that is on right hand side, H is on left hand side. So we can say as compared to this, our glucose has D configuration. Okay. What you have to check, mainly hydrogen and OH group. Now you can see this structure. What I have done in this last structure, I have exchanged the place of hydrogen and OH. You can see here CHO and CH2OH, they both are as such, but position of H and OH, it is different here. So if these two have exchanged their place, then the configuration will be L configuration. The configuration is said to be L configuration. What you have to check, position of alcohol and hydrogen. If alcohol group is on left hand side and hydrogen is on right hand side, the configuration is L. If alcohol is on right hand side and hydrogen is on left hand side, then the configuration is D configuration. Okay. So this is called DL configuration, and according to DL configuration, the structure of glucose that we derived in previous session, that is D plus glucose. Now this plus sign, I am going to discuss it. This plus sign shows it is dextrorotatory. Now what is that? I am going to discuss it further. First, look at this point, cyclic structure of glucose. Now, we have derived this structure. It is the structure of glucose. Now here, you can see, cyclic structure is not there. It is a linear structure with 6 carbon in it. Now, structure of glucose explains some reaction of glucose, but some other reaction, it can't be explained by this structure. Some reactions can't be explained by this linear structure of glucose. For that, we have to derive another structure of glucose, means another isomer of glucose. Now, what are that reactions? That reaction are as follows. You can see first number. In glucose, you can see CHO group is there. This CHO group is there. Now, if simple alkyl chain is there in the structure, this CHO group will give us Skiff taste. Skiff's taste it will give, but glucose does not give Skiff's taste. So we can say that this CHO group is not free in glucose. This is the first reaction. Again, in structure, linear structure, CHO group is free. Now this free group should give skip state test. This free group should give skip test, but glucose, when we react glucose in skip test, it does not give reaction. From that we can say that this CHO group is not free, is not present in the structure. Now second reaction, due to free CHO group, it should give addition reaction with sodium hyposulfite, NaHSO3, sodium hyposulfite. It should give, but when we react glucose with NaHSO3, it does not give any addition reaction. So this is the second failure reaction. First one was skip test. Second one is addition reaction of NaHSO3. Now the third one. Now when we perform acetylation reaction on glucose, it gives us pentaacetate product that we discussed in previous session. When we react glucose in acetylation reaction, it gives us pentaacetate product. Now if we react pentaacetate with NH2OH hydroxylamine, then it should give addition reaction. With pentaacetate, this hydroxylamine should give addition reaction, but this when we react pentaacetate product of glucose with NH2OH, it does not give that reaction. Means again there is no free CHO group available in the structure. Now next point, fourth reaction, that is failure. Glucose has two crystalline form, alpha glucose and beta glucose. Now alpha glucose is obtained from concentrated solution of glucose using crystallization method at 303 Kelvin temperature. This is how we can obtain alpha form of glucose. How we can derive? Make a solution, concentrated solution of glucose, and apply method of crystallization at temperature 303 Kelvin. Now beta form of glucose we can derive from saturated solution of glucose, and we have to perform crystallization technique only, but the temperature is 371 Kelvin temperature. You can see the major difference is in temperature. Two forms of glucose can be separated using this temperature. So this is also not explained by linear structure of glucose. So this non-linear behavior of glucose leads us some another structure of glucose. You can say this is the normal linear structure of glucose. These both are the cyclic form. One is alpha, one is beta form. You can see in this structure we have total 6 carbon, 1, 2, 3, 4, 5, 6. 6 carbon are there. 1 number, 2, 3, 4, 5, and this is 6th. There is a ether linkage, O and R. There is a ether linkage between carbon number 1 and carbon number 5. This forms a cyclic structure. And here in this structure you can say OH is on left hand side, hydrogen is on right hand side. Another structure, the same structure is there. Same structure is there, but the position of alcohol and hydrogen is different here. You can see alcohol group on first number carbon is on right hand side and hydrogen is on left hand side. Here also between carbon number 1 and carbon number 5 ether linkage is there, and this is called alpha form of glucose, this is beta form of glucose. Okay, so there are three structures possible for glucose. First, linear structure, then cyclic alpha structure, and cyclic beta structure. Total three structures are possible in glucose. Further, you can see CHO group forms a cyclic bond with C5 in structure A and B. Only difference is configuration of OH in carbon number 1. Then here you can see in these two structures there is configuration change on carbon number 1 only. Only one carbon has different configuration. So this type of structure, they are called anomers. You can see structures that has different configuration in only one carbon, that are called anomers. Alpha and beta glucose are anomers. Now this cyclic structure, these both structures can be drawn as these two structure. You can see what is the difference here. Check out the position of hydrogen and OH group here. It is different from each other. In alpha D glucose, OH is on downside. In beta D glucose, OH is on upper side. So this is the cyclic form of glucose, alpha form and beta form. Now let me discuss about dextrorotatory compound and levorotatory compound. Now in that, here you can see these both are light waves, and here the waves of light are in same direction. You can see in both case the waves of light are in same direction, parallel to each other. So it is called plane polarized light. Both are plane polarized light. When it passes through a crystal or a solution, you can take, and the direction of that wave that changes itself. You can see the direction of light waves that changes here. In first case, the rotation of waves are in right hand side. If the rotation is on right hand side, this compound or solution is called dextrorotatory. If light waves are rotated towards right hand side, then that compound is called dextrorotatory. Here you can see the angle is there. This angle we can measure using some specific instrument. This angle is also important, that will be useful in next theory also. Second case, here you can see the light waves that imparts on the crystal, it is the same light waves, but here the rotation, it is on left hand side. You can see the direction of waves that changes itself and becomes slightly more on left hand side. The rotation is on left hand side rotation, so that is called levorotatory compound. This crystal or solution, that is called levorotatory. So an angle here is this angle. You can see the angle between these two waves. This angle is again useful in next theory also. So this is dextrorotatory and levorotatory. Dextrorotatory, that is denoted by plus sign. Okay. dextrorotatory compound that is denoted by plus sign before the name, and levorotatory it is denoted by negative sign before the name. As example, you can see this glucose is called D plus glucose. This plus sign that shows glucose is dextrorotatory compound, means when we pass a plane polarized light through glucose crystal, it will shift the direction of light waves in right hand side. The rotation will be on right hand side. So that is the dextrorotatory or plus glucose, and negative means levorotatory compound. Okay, so that's it for today. Thank you.